106. That is the number of confirmed tornadoes that came out of the March 10th through 12th, 2026 outbreak alone, the one that sent a long-tracked EF3 tearing through southern Kankakee, Illinois, and into Aroma Park, damaging over 500 buildings and killing one person, then crossing the state line into Indiana and killing 2 more in Lake Village. The one that produced what may be record-breaking hailstones in the Kankakee area, stones measuring 5 to 6 inches in diameter, large enough, if confirmed, to shatter the previous Illinois state record of 75 inches. 106 tornadoes from a single outbreak, 3 fatalities, 16 injuries. And by April the 16th, 2026, that event is not the worst thing the 2026 season has produced. It is not even the most recent thing. Because in the 5 weeks between the March outbreak and mid-April, the central United States has been absorbing blow after blow. The March 5th through 7th outbreak that killed a mother and daughter in Major County, Oklahoma, when an EF2 tornado threw their vehicle off U.S. Highway 60. The early March Michigan outbreak that killed 4 people, including a 12-year-old boy. The April 13th through 15th outbreak that generated 14 tornado reports in its first 2 hours, produced a particularly dangerous situation warning in Wisconsin, sent overnight tornado warnings through Ann Arbor and Metro Detroit, collapsed the wall of a Michigan ice arena, and triggered Big Falls Dam emergency evacuations in Wisconsin as rivers ran at levels they had not reached in living memory. And now, as the dust from all of that has not yet fully settled, as the survey teams are still walking fields in Kansas and Iowa and Wisconsin counting damage tracks, as utility crews are still working to restore power in communities that have been hit multiple times in the same month, the atmosphere is reloading. The Storm Prediction Center is watching a setup develop that carries a moderate risk designation at day 3. And the most important, most alarming, most consequential thing about what is coming is not the risk level on the map. It is the context surrounding it. Because this outbreak is not arriving into a fresh, recovered, fully operational system. It is arriving on top of everything that has already happened. And that changes everything about how bad this is about to get. Here is the thing about compound disasters that rarely gets explained clearly enough in the day-to-day weather. Briefing. Each successive event in a sequence does not add to the damage linearly. It multiplies it. The first flood saturates the soil. The second flood, landing on already saturated soil, runs off faster, reaches rivers sooner, raises water levels higher, and produces flash flooding in places that would have absorbed the same rainfall safely 2 weeks ago. The first tornado damages a neighborhood. The second tornado, arriving before the first set of debris has been cleared, sends that debris airborne again as additional projectiles at a structure that is already compromised. The first power outage depletes the emergency resources of the utility companies. The second outage arrives when those same companies are still stretched from the first. These are not theoretical multiplier effects. They are the documented operational reality of what is happening right now across the upper Midwest and Great Lakes corridor of the United States. Rivers across northern Michigan and Wisconsin were already at flood stage before the April 13th outbreak even began. Already. Snowmelt from the winter, combined with above-average spring rainfall, had the region running at its wettest early spring on record before the week's first severe storm fired. By the time Tuesday's enhanced risk event delivered another 2 to 3 inches of rainfall on top of soils that had already absorbed everything they could hold, the flooding that resulted was not measured in inches above flood stage. It was measured in dam failures and levee breaches and preventative evacuations in communities where the water emergency services were already stretched from the previous week's events. In Waupaca County, Wisconsin, the Big Falls Dam was actively in danger of failing during the April 14th and 15th flooding event. Emergency management officials ordered preventative evacuations downstream from the dam as the Little Wolf River rose to levels that threatened to overtop the structure. Officials reported that every dam reservoir in the county was completely full and under active monitoring simultaneously. Every single one. In Sheboygan, Michigan, a levee breach on the Little Black River triggered evacuation orders for low-lying areas of the city, with residents told to travel south. This is not the prologue to a disaster. This is an ongoing, compounding disaster that has been accumulating damage since before April even began. And the system bearing down from the west, the moderate risk event, the deep upper trough ejecting eastward with ML Cape values projected at 2,500 to 3,500 joules per kilogram, with 40 to 60 knot winds at 850 to 700 millibar levels, with dew points in the mid to upper 60s, feeding northward from a Gulf of Mexico that has been delivering moisture into this corridor all month. That system is about to land on top of all of it. There's a specific term that meteorologists use for what happens when you combine a loaded convective environment with saturated soil, elevated river levels, and infrastructure that has already been partially compromised by previous events. They call it a high-impact scenario. Not a technical term, a descriptive one. a scenario where the atmosphere's output intersects with ground-level vulnerability to produce consequences that exceed what the meteorological numbers alone would suggest. A half-inch of rain on a dry day in June is a nothing event. A half-inch of rain falling on top of the Manistee River when it is already cresting at 17. 8 feet near Sherman, Michigan, a level the NWS specifically flagged as expected to exceed the river's existing record, is a flash flood emergency. The same half-inch, completely different consequence, and that is the multiplier at work everywhere across this corridor right now as the next system approaches. Let me be precise about what the forecast models were showing by midweek for Friday's event, because the specificity matters and the numbers deserve to be read rather than paraphrased. The SPC's Day 3 outlook, issued while the Tuesday Enhanced Risk event was still ongoing, placed a moderate risk over the core threat area. That is level 4 of 5. That is one step below the rarest designation in the SPC's toolkit, a high risk, which the SPC has issued only 6 times in the entire 2020s decade. The moderate risk designation is issued only when forecasters have high confidence that a widespread severe weather outbreak is likely, not possible, not probable, likely. The atmospheric setup supporting it was described in the SPC's own technical language with terms that deserve attention. MLKP of 2,500 to 3,500 joules per kilogram across the warm sector. Deep layer wind shear of 50 to 60 knots. A potent upper trough from Montana through the southwest, ejecting eastward over the plains and upper Midwest. A lee low deepening over the central and southern high plains into western Oklahoma. A second surface, low near the mid-Missouri Valley tracking northeast. A dry line extending from the high plains, low toward the western Oklahoma and Texas panhandle border. A cold front oriented from eastern Minnesota into central Kansas at midday. Ahead of all of those surface features, a warm sector with dew points in the mid to upper 60s Fahrenheit and temperatures running into the low 80s. The SPC's own internal discussion specifically flagged a corridor stretching from northeast Iowa into central Wisconsin as potentially producing stronger tornadoes, noting that low-level storm relative helicity would be maximized there, that mixing ratios were approaching 14 grams per kilogram, genuine tropical moisture values, and that forecast hotographs were showing the large curved shapes that tornado meteorologists associate specifically with tornadic supercell environments. The forecast even specified that any supercells capable of remaining discrete and organized in the warm sector south of the frontal boundary would be capable of producing tornadoes rated EF2 or EF3. Those two ratings. EF2 and EF3. Those are the ratings that destroy houses rather than damaging them. Those are the ratings that produce the kind of damage where the structure is simply not there anymore, where the foundation slab is swept clean, where the forensic reconstruction of what happened requires the kind of painstaking survey work that takes teams weeks. That is the ceiling this setup was carrying going into Friday. And it was being forecast with the kind of model-to-model, day-after-day consistency that leaves very little room for the hopeful interpretation. There is something else about Friday's setup that distinguishes it from what happened Monday through Wednesday, and it is the element that carries the most direct threat to human life in ways that the overall risk level on the SPC map does not fully communicate. Friday was forecast to run 2 separate severe weather regimes simultaneously. The crashing cold front sweeping through the northern corridor from Iowa to Illinois, and the southern dry line firing discrete supercells across Kansas, Oklahoma, and into North Texas. The presence of 2 simultaneous regimes produces a specific operational problem for the warning system that is worth understanding clearly. Tornado warnings are issued by the local National Weather Service office covering the geographic area where the radar-detected circulation is occurring. When one supercell is producing warnings in northwest Oklahoma, and a separate system is simultaneously generating mesovortex circulations along the cold front in central Iowa, those warnings are being issued by different NWS offices covering different geographic areas. The warning infrastructure handles this. It was built for exactly this. But the end user, the person receiving the alerts, is not a distributed system. They are one person with one phone, receiving tornado warnings from multiple storm systems that are operating in geographically separate areas, trying to determine which warnings apply to their specific location, whether the southern system will reach them or whether the northern system is the threat they should be responding to. That cognitive load, placed on top of a week of accumulated severe weather warnings, is where outcomes start to diverge from what the forecast quality alone would produce. And there is a harder version of this problem embedded in Friday's specific setup that the SPC's own technical discussion addressed directly. The cold front sweeping southward was forecast to eventually catch and overtake the southern dry line if it moved faster than medium range guidance suggested. If that happened, the dry line regime's window for producing organized discrete supercells would shrink dramatically. The discrete supercell threat would be replaced earlier in the afternoon by a squall line, a quasi-linear convective system. And the nature of the tornado threat would shift from the relatively well-warned multi-minute lead time supercell tornadoes to the embedded, fast-developing, short-duration QLCS mesovortex tornadoes that the warning system has the hardest time catching before they are already on the ground. This is not a hypothetical concern. QLCS tornadoes have caused fatalities specifically because the warning was issued after the tornado had already dissipated, not before it touched down. The physical mechanism, a mesovortex spinning up along the leading edge of a squall line in seconds to tornado strength, touching down, causing damage, and lifting before the radar data can be processed and a warning can be transmitted, is an inherent limitation of current Doppler radar scanning rates and the processing time required between raw data and issued warning. When the SPC flagged an aerially extensive tornado risk from both discrete supercells and QLCS mesovortex circulations, they were explicitly acknowledging that a significant portion of Friday's tornado threat existed in the warning gap, the zone where the atmospheric physics and the warning infrastructure's response time were not perfectly synchronized. For communities in that gap, the only preparation that saves lives is not the warning that arrives in time. It is the preparation that was already done before the day began. The flooding dimension of this event deserves its own serious treatment, because it is the component that in many historical outbreak sequences has ultimately produced more casualties than the tornadoes themselves. The Weather Prediction Center specifically flagged as slight risk for excessive rainfall across portions of the mid-Mississippi Valley into the Central Plains for Friday. In isolation, a slight risk for excessive rainfall is a relatively modest designation. In the context of soils that had been absorbing heavy rainfall for a week straight, rivers that were already at or above flood stage across multiple watersheds from Michigan to Wisconsin to Iowa, and communities where the drainage infrastructure was already operating at or near capacity from previous rounds, a slight risk for excessive rainfall translates directly into a high probability of flash flooding in vulnerable areas. The WPC's own language about repeated rainfall events producing 1 to 2 inches with embedded higher totals falling on the same saturated landscape was not advisory language. It was documentation of a compounding hazard. Every inch of rain that fell on Friday was falling on ground that could hold less than it could a week ago. Every stream that crested Friday was cresting from a higher baseline than it would have in a season where this week had not already happened. The flooding on Friday was not a secondary hazard in the way flooding is described as secondary when it follows a tornado. On Friday, in this specific landscape context, flooding was a co-equal primary hazard affecting a potentially larger geographic area than the tornado and wind threat combined. AccuWeather meteorologist Alex Duffus said at the beginning of the 2026 severe weather season, something that was accurate then and has become increasingly accurate with each passing week of this spring, flash floods and damaging wind gusts can be just as destructive as tornadoes and often impact a much larger area. He said it before any of this happened, before the March outbreaks, before April, before the saturated soils and the record river levels and the dam emergencies and the levee breaches. He said it as a general seasonal forecast for a year when the atmosphere would favor repeated rounds of severe thunderstorms with heavy downpours in addition to tornadoes. And now, in mid-April, it is no longer a forecast. It is a description of what has already happened and a preview of what Friday is about to deliver. There's a piece of data from the overall April outbreak sequence that deserves to be stated plainly before we close, because it contextualizes everything else. The average number of tornadoes in the entire month of April across the United States, based on the historical record from 1991 to 2020, is approximately 182. The April 2026 outbreak sequence from April 13th through April 17th alone was on track to approach or exceed a substantial fraction of that monthly average in a single week of activity. And that week was not yet over when Friday's moderate risk event loaded up. The 2026 spring severe weather season had been characterized since before it began as front-loaded, weighted toward March and early April rather than the peak May pattern that more typical seasons produce. What that front-loading has meant in practice is that the corridor from the southern plains to the upper Midwest has been receiving compressed, repeated, sustained severe weather forcing for going on 6 weeks straight. The soils know it, the rivers know it, the infrastructure knows it, the emergency management systems know it, the survey teams still working in Kansas and Iowa and Wisconsin and Michigan know it, and the atmosphere, operating on its own schedule with complete indifference to what the calendar says or how tired anyone on the ground has become, is loading up again. The moderate risk for Friday is not a warning that something unusual is coming to an otherwise normal landscape. It is the latest entry in a sequence that has been rewriting what the spring of 2026 means for the communities in its path. And the reason this outbreak is about to get worse is not simply because a powerful atmospheric system is arriving. It is because that system is arriving at the exact moment when the region it is targeting has the least capacity to absorb what it is bringing. That is the compounding that forecasters measure in numbers. And that is the reality that people in its path have to live through. Stay informed, stay prepared, and understand that severe weather in April 2026 is not a series of isolated bad days. It is a season-long siege, and it is not finished yet.